In this video, we'll explore why this course is built around a team project instead of traditional exercises. If you've taken programming courses before, you might be used to homework assignments with a starter code and clean instructions. This course works differently, and there are important reasons why. Let's start with a fundamental truth. You cannot master software engineering just by talking about it. You need to build something real to truly learn. The real challenges of software engineering only appear when you work with others to build and improve an actual system over time. Regular homework problems simply don't reveal these issues. That's why this course focuses on a team project that you'll work on throughout the entire semester. What's the difference between traditional exercises and project-based learning? Let's look at what you typically get in traditional exercises. In most programming assignments, you get a starter code with the architecture already in place. Instructions tell you exactly what to add and where. The difficult decisions, how to decompose a problem, what interfaces to use, how to manage dependencies, are all made for you. There's little or no interaction with teammates and minimal attention to long-term maintainability. Project-based learning raises both the scale and the importance of your work. You'll build an application that multiple people care about. You'll live with the design and implementation decisions you made weeks earlier. And you'll see firsthand how requirements, design, code, and tests interact over time. This is where software engineering becomes real. Working on a real project reveals the core problems that software engineering is designed to solve. First, there is coordination and communication in a team. How do you make sure everyone knows what they're working on and how it fits together? Second, decomposing a system into sensible modules. What's the right way to break down your application? Third, managing changes across versions and iterations. How do you add features without breaking what already works? And finally, keeping quality from collapsing as the code base grows. These are the real challenges, and you only encounter them when you're building something substantial. Let's walk you through how this course is structured. The first few weeks are a boot camp to get you ready. You'll form teams, settle on a project idea, practice basic development process and tools, and learn the building blocks you'll use throughout the project. This latter is the part that I will be teaching you about building AI-enabled applications, so to speak. After the bootcamp, the course moves forward in a series of iterations. Each iteration has goals, a plan, a build phase, and a retrospective. You'll refine your specifications and designs based on what you learn, and you'll gradually take more ownership of decisions and trade-offs. This is how real software development works. Let's get more specific about what happens in each iteration. You and your team will plan the iteration and coordinate on who builds what. You'll build, test, and ship working software every few weeks. You'll demo your progress, gather feedback, and adjust your priorities. And you'll adapt when things break or take longer than expected because they will. Remember, the project is not just an extra task tacked onto the course. It's the main way you will learn software engineering. This course is built on self-directed learning. In a project context, that has a specific meaning. Self-directed learning means you help decide what to build, not just how to implement a pre-given spec. You identify what you need to learn, frameworks, libraries, tools, to make progress. You choose strategies like experiments, prototypes, or additional readings to fill gaps in your knowledge. And you evaluate your own progress against the goals your team sets. Now, this doesn't mean you're on your own. The instructional team provides a structure through the bootcamp, iterations, and milestones. You'll get feedback on your specs, code, test, plans, but they will guide you through questions that help you think more clearly, not a step-by-step instruction that tell you exactly what to do. Your teammates also share responsibility for the project's success. So in sum, by working through a real project with a real team, you'll build both technical skills and the confidence that you can tackle complex software problems.